Hello, in this lecture we'll find out the area of a square. In the drawing we have triangle ABC. Triangle ABC is a right triangle, angle ABC equals to 90 degrees. We know that side AB equals to 5 units in its length, side BC equals to 12 units in its length, and inside the right triangle ABC we have this square DEFG. And our mission is to find out the area of this square. So first of all, we'll implement the Pythagoras theorem in the right triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle ABC, the hypotenuse is AC, therefore the square of the hypotenuse is AC squared. And it must be equal to AB squared plus BC squared. Okay, again, in the right triangle ABC, by PT is the relation for Pythagoras theorem. According to the Pythagoras theorem in the right triangle ABC, AC squared equals to AB squared plus BC squared. So AC squared, it is the square of the hypotenuse, equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25, plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. So in conclusion, we found out that AC squared equals to 25 plus 144. So AC squared equals to 25 plus 144 is 169. We take a root out of this equation, and finally we get that AC, the length of the hypotenuse AC equals to the square root of 169, that is 13. So here, the length of the hypotenuse AC is 13. In the next step, we define angle ACB. This angle is alpha. And we focus on the right big triangle, triangle ABC. On the right big triangle, triangle ABC, this angle equals to alpha. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. So the missing angle must be equals to 90 degrees minus alpha. So we define that 90 degrees minus alpha equals to beta, and therefore the missing angle here equals to beta. If 90 degrees minus alpha equals to beta, it means that 90 degrees minus beta equals to alpha. If you just add alpha and subtract beta from this equation, we get that 90 degrees minus beta equals to alpha. We have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. AC is the hypotenuse on the right triangle ABC, therefore it is absolutely a straight line. So if we focus on the lower side of the straight line AC at point E, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So 90 degrees plus the missing angle in total must be equal to 180 degrees. So the missing angle here must be equal to 90 degrees in its size. and in the lower side of the straight line AC at point D, here the sum of the angles must be equal to 180 degrees. So which angles we have here? We have this is again a right angle plus the missing angle. In total, they must be equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees in its size. In the right angle GE, in the right angle GEC, in this right angle GEC, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle here equals to beta. BC is one side of the right triangle ABC, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line BC at point G, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So beta plus 90 degrees plus the missing angle, in total they must be equal to 180 degrees. So the missing angle here must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees equals to 180 degrees. Okay, this is the sum of the angles on the upper side of the straight line BC at point G. So the missing angle here equals to 90 degrees minus beta. But 90 degrees minus beta equals to alpha. Therefore the missing angle here equals to alpha. In the right triangle FBG, in this right triangle, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta. Here, 90 degrees minus alpha equals to beta. So the missing angle here equals to beta. AB is one side of the right triangle ABC, therefore it is absolutely a straight line. So if we focus on the right side of the straight line AB at point F, here the sum of the angles must be equal to 180 degrees. So which angles we have at the right side of AB at point F? We have this angle that is beta plus this angle that is 90 degrees plus the missing angle. In total they must be equal to 180 degrees. Therefore the missing angle here must be equal to 90 degrees minus beta. Okay. The missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle here equals to alpha. So in this moment we have in total 4 right triangles. 1, 2, 3, and the big right triangle, triangle ABC. In total we have 4 right triangles, and all the 4 right triangles are similar to each other. Why? Because they have exactly the same angles. Each right triangle consists of 3 angles, alpha, beta, and 90 degrees. So all the 4 right triangles are similar to each other according to angle similarity rule. So from the fact that all the 4 right triangles are similar to each other, we can derive a specific relationship between their sides. So for example, we have the big right triangle ABC is similar to this one right triangle, triangle FBG. Repeat again. The big right triangle ABC is similar to the small right triangle, triangle FBG. And for that reason, they're similar to each other according to angle similarity rule. And therefore, the following relationship exists between their sides. Again, this small right triangle FBG is similar to the big right triangle ABC according to angle similarity rule. So, first of all, we define side BG of the small right triangle FBG as X. So what is the length of side GC? GC equals to BC minus BG. Again, BC minus BG equals to GC. So GC equals to BC, that is 12, minus BG, that is X. So in total, GC equals to 12 minus X. We define one side, the length of one side of this square DEFG is equals to L according to our definition. Therefore, all the three other sides must also equal to L because of the fact that all the sides of any square are equal to each other. Okay. So I repeat again. The big triangle ABC is similar to the small right triangle FBG. And from the fact that the big triangle ABC is similar to the small triangle FBG, we will derive that the following relationship exists between their sides. We will derive that X over L in the right triangle FBG is equal to 12 over 13 in the right triangle ABC. Repeat again. From the fact that the right triangle FBG is similar to the right big triangle ABC, we derive that X over L in the right triangle FBG is equals to 13 over 12 in the right triangle ABC. So according to equation 1, X over L equals to 12 over 13. Here we multiply this equation 1 by L, and we get that according to equation 1, X equals to 12L over 13. Likewise, the big right triangle ABC is similar to this right triangle AGC. Repeat again. The big right triangle ABC is similar to the right triangle AGC. And from the fact that the right triangle ABC is similar to the right triangle AGC, we will derive that 12 minus X over L in the right triangle AGC is equals to 13 over 5 in the right triangle ABC. Repeat again, from the fact that the right triangle ABC is similar to the right triangle AGC, we derive that 12 minus X over L in the right triangle EFG is equals to 13 over 5 in the right triangle ABC. So here we cross multiply this equation 2, and we get that according to equation 2, 5 times 12 minus x equals to 13L. We have already found out that x equals to 12L over 13 according to this equation 1. So we can substitute x in this equation 2 by the value of x for this equation 1. And we already found out that x equals to 12L over 13. So according to equation 2, we have here 5 times 12 minus x, and x is 12L over 13 according to this equation 1. So we substitute x in this equation 2 by 12L over 13, and it is equals to 13L. So according to equation 2, 5 times, inside the brackets we have 12 minus 12L. Here we multiply 12 by 13 and then we divide it by 13 in order to work on factor with this expression. And we get that 12 times 13 is 156 minus 12L. In total, in the numerator we have 156 minus 12L over 13 equals to 13L. Here we multiply this equation 2 by 13, and finally we get that according to equation 2, 5 times 156 minus 12L equals to 13L times 13 is 169L. Here we'll open the brackets on this side of equation 2, and we get that according to equation 2, 5 times 156 is 780. 5 times minus 12L is minus 16L. This is equal to 169L. Here we add 60L to this equation 2, and we get that according to equation 2, 780 equals to 169L plus 60L is 229L. Here we divide this equation 2 by 229, and we get that according to equation 2, L equals to 780 over 229. 780 over 229 is equals to 3.406. So found out that L, that is the length of one side of square DEFG, L equals to 3.406 units. And we know that the area of any square, so the area S equals to one side squared. That is to say it is equals to L squared. So S equals to L squared, the area of square EDEF equals to L squared. L is 3.06, therefore L squared is 3.406, so L squared is 3.406 squared. And 3.06 squared is equals to 11.6016. In conclusion, found out that the area of this square DEFG equals to 11.6016 square units. And that is the answer to the question. So in the next step, I will summarize the lecture. In this lecture, we found out the area of this square DEFG. So in the drawing, we have a right triangle. Triangle ABC is a right triangle. That is to say, angle ABC equals to, this angle equals to 90 degrees. In addition, we know that side AB equals to 5 units in its length, side BC equals to 12 units in its length. Again, our mission is to find out the area of this square DEFG. So first of all, we implemented the Pythagoras theorem on this right triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle ABC, the hypotenuse is AC, therefore the square of the hypotenuse is AC square, and AC square equals to AB square plus BC square. Repeat again, in the right triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. So AC square, that is the square of the hypotenuse, equals to AB square. AB equals to 5, therefore B square is 5 square, that is 25, plus BC square. BC equals to 12, therefore BC square is 12 square, that is 144. In conclusion, we found out that AC square equals to 25 plus 144. 25 plus 144 is 169, so AC square equals to 169. We took a root out of this equation and found out that the length of the hypotenuse AC is 13. So, yeah, the hypotenuse AC equals to 13 units in its length. Okay. So in the right, we focus on the right triangle ABC. In the right triangle ABC, we define this angle as alpha. So in the right triangle ABC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees it is equal to 180 degrees. That is the sum of the angles in any triangle. So the missing angle here equals to 90 degrees minus alpha. But we define 90 degrees minus alpha as beta, therefore the missing angle here equals to beta. Okay? And we have also the rule that the sum of the angles on one side of a straight line is equals to 180 degrees. So AC is the hypotenuse of the right triangle ABC, so as hypotenuse, it is absolutely a straight line. So if you focus on the straight line AC, at the lower side of the straight line AC, here at this point, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have here? Here, this angle is the right angle, it is equal to 90 degrees. So 90 degrees plus the missing angle, in total it must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees. Likewise, if we focus on the lower side of the straight line AC at point E, here, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So 90 degrees plus the missing angle here must be equal to 180 degrees. So the missing angle here must be equal to 90 degrees. Okay? So in the right triangle GEC, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha is beta, therefore the missing angle here equals to beta. BC is one side of the right triangle ABC, therefore it is absolutely a straight line. So if you focus on the upper side of the straight line BC at point G here, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So here, which angles we have at the upper side of BC at point G? We have this angle that is beta, plus 90 degrees, plus the missing angle here. In total, the sum of those three angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles on the upper side of the straight line BC at point G. So the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha. Therefore the missing angle here equals to alpha. So in the small right triangle FBG, this angle equals to alpha, this angle equals to 90 degrees. Therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle here equals to beta. Actually, in the right small triangle ADF, this angle equals to beta. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle here equals to alpha. In conclusion, we actually found out that all the four right triangles here are similar to each other. Why? Because of the fact that they have exactly the same three angles, alpha, beta, and 90 degrees. So all the four right triangles, 1, 2, 3, and the right big triangle ABC, they are all similar to each other. From the fact that all the right triangles are similar to each other, we can derive that a special relationship exists between their sides. So first of all, we know that the right big triangle ABC is similar to the small right triangle FBG. So we defined side BG as x, therefore side GC equals to BC minus BG. BC is 12, BG is x, therefore GC equals to 12 minus x. We define one side of this square as L, therefore all the three other sides must be also equal to L because of the fact that all the sides of any square are equal to each other. Okay, so this small right triangle FBG is similar to the big right triangle ABC. Repeat again. The right triangle ABC is similar, this is the sign of similar, to the right small triangle FBG. And from the fact that the right big triangle ABC is similar to the right small triangle FBG, we will derive that we will derive that FG over BG equals to, again, we derive that BG over FG is equals to BC, so BG over FG over BG in the right small triangle FBG is equals to BC over AC in the right big triangle ABC. So BG is X and FG is L. Therefore BG over FG is X over L. Okay, and here BC is 12 and AC is 13. Therefore BC over AC is 12 over 13. Okay, BC over AC is 12 over 13. So we conclude found out that according to equation 1, x over L equals to 12 over 13. Here we multiply this equation 1 by L, and finally found out that x equals to 12L over 13. Okay. Likewise, we know that the big right triangle ABC is similar to this right triangle, triangle AGC. Again, the big right triangle ABC similar to this right triangle, triangle AGC. And again, the big right triangle ABC is similar to the right triangle AGC. And from the fact that the big triangle ABC is similar to the right triangle AGC, we derive that GC over EG in the right triangle EGC is equals to AC over AB in the right triangle ABC. Okay, so GC is 12 minus X and EG is L. So GC over EG is 12 minus X over L. 12 minus X over L, and it is equals to AC over BC in the right triangle, triangle ABC. AC is 13 and AB is 5. So AC over AB is 13 over 5. So it is 13 over 5. So in conclusion found out the 12 minus X over L equals to 13 over 5 according to this equation, equation 2. Here we cross multiply this equation, equation 2, and found out that according to equation 2, here we have 5 times 12 minus X equals to 13L. According to equation 1, X equals to 12L over 13, so we can substitute X in this equation, equation 2, by the value of X from this equation, equation 1. We did it and found out that 5 times 12 minus X, and X is 12L over 13 equals to 13L. So here we multiply 12 by 13 and then we divided by 13 in order to have a common factor with this expression. So 12 times 13 is 156. So in total, in the numerator of this expression, we have 156 minus 12L divided by 13. And it is equals to 13L. Here we multiply this equation, equation 2 by 13, and finally found out that 5 times 156 minus 12L equals to 13 times 13L is 169L. So here we open the brackets on this side of the equation 2 and found out that 5 times 156 is 780 minus 5 times 12L is 116L, and it is equal to 169L. Okay, so we added 60L to this equation, equation 2, and found out that according to equation 2, 780 equals to 169L plus 60L is 229L. So we can found out that according to equation 2, 780 equals to 229L. We divided this equation by 229 and finally found out that L, that is the length of one side of this square DEFG, L equals to 780 over 229. 780 over 229 is 3.406. And you know that the area of any square equals to the square of one side. Again, the area of any square is equals to the square of one side, the length of one side squared. This is to say the area of square DEFG will be equal to the length of one side squared, that is L squared. And L equals to 3.406. And therefore L squared equals to 3.406 squared. 3.406 squared equals to 11.6016. In conclusion found out the area of this square DEFG is equals to 11.6016 square units. Okay, thank you very much.